Alright, so in this video, I'm going to show you how to use 4 different error methods to calculate forecast accuracy for your forecast. Alright, so to begin with, the forecast that we are going to use is called naive forecast. So we're not going to use any sophisticated forecasting method to explain this rules to you or this error methods to you. But in principle, you could use these error methods for any kind of complicated forecasting method. So the forecasting method that I'm going to use is called again naive forecasting method. So we went over this in class. So the naive forecast. All right. So what the naive forecast basically says is that I'm just going to be very naive or short-sighted, and I'm going to forecast this period's sales as the last period sale. Okay. So for example, in week 1, if I want to forecast, I basically don't have any data for week 0, so I cannot forecast that. All right. However, for week 2, I do have data for week 1, and I'm going to say my forecast for week 2 is my sales for the past week, which is week 1. Okay. Similarly, my forecast for week 3 is going to be the sales for week 2. Okay. Similarly, the forecast for week 4 would be sales for week 3. Okay. So I'm just gonna drag it down to fill up the rest of the rows. But basically, it's a very naive or short-sighted forecasting method where I'm saying I'm forecasting this week's sales is gonna be my last week's sale. Okay. And then once we have this forecast, now we should be able to tell how good this forecast is. Okay. So to say, if we have 2 different forecast methods, let's say we have a naive forecast method, and then we come up with a complicated, sophisticated, a better forecast method. But how do you say that it's better? So the way we can say is that we can use one of these error measures, okay, that we're going to talk about today. So the error measures that we're going to talk about are MFE, MAE, MSE, and MAP. And you want to look at, or you want to apply a forecasting method which has a lower error. Okay, so a forecasting method with a lower error is a better method. Okay, so what I'm gonna show you is how to calculate this forecast errors using this methods. Okay, or in other words, how to calculate forecast accuracy using this methods. So first, I've also kind of noted down here the formulas, which you could also do. So the first method that we're going to talk about is called MFE, and it just means mean forecast efficiency. Sorry, mean forecast error, not efficiency, forgive me. So it's called mean forecast error, okay? And to do that, we need to first calculate. If you look at the formula, there are a bunch of different notations, so we don't know what's the meaning of right now, but we will get to each of those. So the first thing to calculate any forecast accuracy, such as MFE, MAE, MSE, and MAPE, we need to calculate the forecast error. So it's kind of a very intuitive concept. So the forecast error is essentially going to be the difference between your forecast and the actual value. Okay. So again, for week 1, we can't calculate forecast error because we don't have a forecast, right? For week 2, we can calculate a forecast error, which is going to be the difference between the real sales data that you have in week 2 and whatever you forecast. Okay, so let's do that. So this minus this. Okay, so you forecasted 17, but the real sales was 21. So the error that you had was 4. Similarly, this minus this, right? So you forecasted 21, but the sales was 19, so you overestimated your forecast by number 2, right? By 2. All right, so you can again drag it down and fill up the row. So these are called the forecast error, and these are also gonna be it's E. Okay, so these are the ones ET. ET. I'm just gonna say this. So this is this. All of this. You see, all of the forecast accuracy measures are dependent on this ET in some way or form. All right. So now let's calculate MFE. So for calculating MFE, all you need is ET. The rest of the things you have. So for example, the other things that you need to take care of is N and K. So what is N and K? So N is the number of rows that you have or number of data that you have, number of data points that you have. Okay. So in this case, we have 1 to 12, right? So we have the data of 12 weeks. So my N is going to be 12. Okay. And what is K? So the K is the number of forecasts that you cannot do at this point. So at this point, I cannot forecast my week 1 sales because using this method, using the knife forecast method, I need the week 0 sales, right? To be able to forecast week 1 sales, which I don't have. So I'm not able to forecast for week 1, right? So I'm not able to forecast for 1 week, which is why the number K would be 1. Okay, so rest of the numbers we have. So let's do it. So what the formula says is that you are summing up all these errors and then you're dividing up by dividing the sum by n minus k, where n equals to 12, there are 12 data points, and k equals to 1 because 1 missing forecast. Okay, so that's all equals to you use the sum function. All of them, and then you divide by n equals to 12 minus k equals to 1. Okay, there you go, 0.4545. So that is your, I'm going to highlight that real quick, and that is going to be your MFE, which is mean forecast error. Okay, all right, so now let's move on to MAE. So one of the problems or one of the issues of a mean forecast error is that you have positives and negatives. And sometimes when you're summing them up, they're canceling, right? But that is not the right thing to do because both are errors, right? So one of the ways you can avoid that problem is to be able to calculate the absolute value, right? So that's what you're going to do next. So the MAE, the long form of that is mean absolute error. So you're just going to take absolute value of all of that and then use the same formula, right? So instead of ET, I'm adding here absolute value of ET. Okay, so let's write down or create the absolute value. So absolute forecast errors. Okay. So it's going to be, you can use a function called adds and just take your forecast error. That's it. You can fill up your, but let's not do this. So you fill up this, and then finally you're going to do sum. So your MAE is sum of all these numbers divided by n minus k. N is 12 and k is 1 because it cannot forecast for week 3.7272. So that is going to be my MAE. Okay. All right. So another way to avoid positive and negative numbers and canceling them in your error calculation is to do a square, right? So that's the second thing that we do, and that's basically the building block for creating your MSE. So you see in MSE instead of E, I have E squared, right? So that's what we're going to do. We're going to create squares. And the full form of MSE is mean squared error. So I'm going to create squared forecast errors. And then now create squares of forecast errors. I can drag it down. Can ignore this word. I'm gonna recreate that. And then so what's gonna be my MSE? It's gonna be the same thing, sum of all of this divided by n, which is 12, minus k, which is 1. Okay. And this is my MSE. Okay. All right. So the final and the last forecast accuracy method that we'll learn about is called MAPE. Okay. And the reason we need that is because both absolute and squared forecast error methods are forecast accuracy methods. They are dependent on the scale of the data. So what we want to do in this case is we want to create a forecast accuracy method that does not depend on the scale of the data. And we can make sure that it does not depend on the scale of the data by dividing it by the data itself, by dividing the error by the data itself. Okay, so we need to again look at the error values, forecast errors, and then we'll divide the error by the data itself, and then multiply that by 100 to just create a percentage value. And then we'll take an absolute of that. So the full form of MAPE is mean, absolute, percentage, error. Okay, so we are going to do first percentage, then going to do absolute, and then going to take the mean. Okay, so let's create the absolute. So before we take the mean, we need to create the absolute percentage errors. All right, so let's create that. So equals to, so first the absolute sign, right? So we're going to start with the absolute function, absolute. Inside I need the error divided by the data itself, right? So let's see. Here is the forecast error divided by the data itself. Okay. And then you want to multiply that by 100, right? To get the percentage. There you go. So you have this number right here. So absolute of ET by YT, so the error, the forecast error divided by the data itself, multiplied by 100, and you're taking absolute. And again, you can fill this up. And finally, you just take a mean of these absolute percentage errors. So I'm just going to take mean, but the mean is in a particular way that you divide it by n minus k. Right, so I'm going to do again sum divided by again n minus k, n equals to 12 and k equals to 1. So there you go. That's your MAPE. So MAPE is the best forecast accuracy method among these three, but it also requires more computational power. So sometimes we will go with MSE and sometimes we'll go with MAPE, but we'll most likely use these two methods more regularly than the others. Okay, so there you go. So that's all of your forecast accuracy methods that you need to know for this class.